Post-processing and GLSL. Three.js post-processing. You're well on your way to being a Three.js expert, but there are a couple of things that you might find interesting to add to your knowledge. So far, everything we've seen on our screen has come from the renderer, but we can use post-processing to play with this image. If you know Photoshop, then think about applying a filter to your rendered image. Three.js comes with a number of post-processing shaders that you can use without writing any fancy code. In this video, we'll look at using 3 of them. There are a number of steps involved in using a post-processing shader when using the Three.js library. First, you create an instance of the Effect Composer class, passing in your renderer as the single parameter. Then you use the addPass method of the composer, adding an instance of the renderPass class. This takes 2 parameters, the scene and the camera. Now we're ready to add a post-processing shader. The first one we'll look at is the glitch pass. This gives the appearance of a glitch in a TV transmission. It's very easily used. Take a look at this address. The template simply includes 100 randomly placed objects created from a low-resolution sphere, radius 1, with horizontal and vertical segments set to just 4. Then in a loop we create a mesh with a randomly coloured material that is flat shaded. We randomly position, rotate and scale this, and then add it to a parent object. In the update method, the parent object is rotated slightly each screen refresh. So far, nothing new. Now we're going to set up a post-processing pipeline. I've added a global variable called composer to the template. Enter composer equals new 3.effect composer renderer. When you use post-processing, you'll need to add additional files to your project. I've combined all the ones we'll need into a file called 3-pp.js, which is stored in my AWS file storage. If you look in settings, you'll see that this is added to the project. In this file, I've combined several files from the examples.js post-processing folder. The minimum you'll need are effect composer.js, copy shader.js, shaderPass.js, and renderPass.js. Then you will need the actual post-processing shader you're using. The previous 4 are required to enable post-processing and to include the actual renderer output. Let's add a renderPass. Enter const renderPass equals new 3.renderPass scene camera. Notice that you include the scene and camera as parameters. Now add this pass to the composer. Composer.addPass renderPass. There are a couple of other steps. First, go to the update function and comment out renderer.render and add composer.render. Oops, now we have a black screen. I did say there were a couple of steps. The second step is we need to set a flag for the render pass. Go back to where we created the render pass and on the next line add render pass render to screen equals true. The last pass in your pipeline needs this property set into true. That's right, we add passes. So you could have several passes that build up the final image, and the last pass has render to screen set to true. So far, it isn't very impressive. We've simply got back to what we had before. Bear with me, it's about to get interesting. The first real post-processing filter we're going to add is going to be something called the glitch pass. This tries to mirror an old-fashioned TV that is struggling to stay on station. Most post-processing filters have a number of options to pass. A glitch pass has an amount value that takes a value between 0 and 1. For this example, we'll take the default. Remember to comment out the render pass render to screen line, then enter const glitch pass equals new 3.glitchPass glitchPass render to screen equals true. Composer.addPass glitchPass. You've got your first post-processing pipeline working. Nice one. Another fun post-processing filter is the film pass. Again, this has several parameters that you can pass to the constructor. Noise intensity, scanlines intensity, scanlines count, and grayscale. Delete, comment out or edit the glitch code and enter const film pass equals new 3.filmpass 1.5 true. Film pass render to screen equals true. Composer.addPass film pass. Nice one. Now we have something that looks like it's being broadcast from the moon. The last filter we'll look at is the dot screen pass. The parameters for this are center, angle, and scale. Delete, comment out or edit the film pass code and enter const.pass equals new 3.screenPass. .pass render to screen equals true. Composer add pass .pass. Another fun effect. So you can see the scope you have with Three.js post-processing filters. And if you learn GLSL code, you could even write your own filter. And the 4 remaining videos in this section